Start recording. Yes, sir. Just once again, I'll pin you. No, sir. They've just finished current electricity, and if I heard my teacher right, they're moving on to heat transfer next. So I don't see them touching on magnetism anytime soon. So I'd be fine with magnetism. Yes, sir. Yes, sir.
On a moving charge or on a charge carrying conductor, current carrying conductor.
Yes, sir.
That is the first instance that we will be looking into without a much delving in how it's being generated. That will be the second part, how it's being generated. What takes for the generation of magnetic field will come as the second part of the dispensation that we are in. Shall we take it this way or you want to swap?
So whatever you say will best assist understanding.
Who asking you, dear? I'm asking you, you're pointing back to me. Which way you want to do? You want to do the first being on face value, magnetic field taken, then the effect of it on moving charge, or you want to know how is magnetic field generated so that you get the genesis of it and accordingly its effect. Which way?
So I think I prefer the second part, the origin story first.
Okay, fine. Let's take the Murphy first. Like, write down then, let us take, write down. Let us take a current carrying conductor. Let us take a current carrying conductor. The effect that it generates, at a certain distance r, the effect that it generates at a certain distance r in accordance with Biot-Savart law, B-I-O-T, a dash, S-A-V-A-R-T. In accordance with Biot, B-I-O-T, dash, S-A-V-A-R-T, Biot-Savart law is expressed as follows. Is expressed as follows. Now, I would like to introduce a term to you, that being electric current element. Good here. What is that term? That is electric current element, or we can just make it amicable by saying electric current or current element. Okay. So there is a current element which I am defining. I am associating with wire. Wire can be of any shape. We take a very small shape. Why do we take a very small shape? We take a very small shape owing to assigning vector to it. If it is in a curvilinear form, we cannot go on changing our direction. So I'm taking a very small element, calling it current element. This current element will have to its merit a direction. It will have to its merit a direction. It can be taken as a vector representation, very small on quantum, but with specified direction. Direction is in consonance with direction of current. Find here?
Yes.
Direction will be in commensurate with direction of current. I take current element, I mark or spot tail of it, and from tail I draw another vector. The vector will be marked position vector, which will position the point of interest. Find here?
Yes.
It will position the point of interest. Now let me draw for the case. What is with us is What is with us is a current. By the way, yesterday you weren't present here. I passed on a link to you. I presume you are not able to get a fully on the same.
Yes, I had other classes.
It was an important event which you missed. She is the principal of ICSC top school in Kolkata. It's ICSC plus IB, and this school has gotten you ICSC topper this year, Manya Gupta.
Yes.
She was Sima Sapru along with HOD of Doon, Mr. Anand Kumar. They were there, and we were speaking about NEP and various other stuff, gamut of issues. Nevertheless, I'll try to see if possible for us, though we have not recorded, but if possible for us, we can assimilate it. Okay?
Yes, sir.
Now, what was to be seen here? This is a wire. Okay? A wire given to us. What we do, irregular shape wire, of course. I'm making it generic. What I'm to do, I'm to assign current element to it. So small, very small. I cannot show you that small. I have taken a certain length, but it's very small in imagination. It's very small length for you. What is this length termed? It is termed current element.
Element.
Where is the tail of it? Of course, over here, what I do, I take another vector, mark it R. What is R for us? R is the position of point P vis-a-vis tail of current element. Okay, yeah?
Yes, sir.
R is position of point P vis-a-vis tail of current element. R is the position of point P wherein we want to find effect due to this current element. Got it?
Yes, sir.
We want to find effect due to this current element. We will take a leap out of their deliberation. We will take a leap out of their experimentation. By there we mean Biot and Sawant. Okay? You are the two scientists. We are to take a leaf out of their work and try to, over here, take credit to it. So what do we have at our merit? We have at our merit a formula. A formula which I am, of course, as we are more into NEP and IB now, we need to accord credits. That is what we need to learn. It's hard way for us to, but we need to learn. This attribute is very important to us. We'll get to know that in IB, whatever point you take, you will have to mention that you have to from there. It's essentially to be mentioned. Otherwise, it form a range of letters. We have not learned it as yet. This is yet to be learned by Indian students, but we need to go there and make a point that whenever anything being taken from anywhere, we need to mention, we need to allocate it to the place where we have been taking it from or we have it. Their mention is a must. So Bharat according to Bharat what I am to do is, I am to first write what were their observations. What were their observations? Because from observation to formulation, it takes a heck of a work. It's not that easy to formulate. First, we need to observe that what are the parameter it depends on. So they found that depends on A, current, B, length of segment taken by an individual, C, position of point of interest, D, the angle between them. To take the verbatim out of their context, being slightly incongruous, I would say they would have come to a conclusion that B field will be inversely proportional to the square of the distance and directly proportional to the cross product. Again, if I am to amalgamate their experimentation with their work on formation, shaping it to the form that it will, what we get to see is, it depends on certain factor, and they being dl cross r by r cubed. Of course, this is the formation. It's not what they did observe. They would have observed it being dependent on R square in inverse proportionality. Proportionality on the length dl and also sine of the angle between dl and r. If you remove the sign of proportionality, you get a constant. And you get to see then from there, dV is equal to mu naught by 4 pi I into dl cross r by r cube. That's what I want to ask you here. What about the result out there? Because the only result which I got to know of Kuldeep is 2580.
Yes, sir.
That is the CIR. Is that the best?
So that does seem to be it. We actually had him over at our campus today for a general Q&A session.
There's nothing better than this time?
So that does seem to be the best because there was nobody else.
My goodness. Well, what happened this time? Anshuman and Guru Prasad did good initially.
So,
Particularly Anshuman. Sorry, Guru Prasad?
so I do not know about them. They didn't show up there, so the scores weren't exactly announced.
They didn't show.
Yes, sir. Kuldeep was the only person. It was more of an informal meet, less than a staged formal event. They just had him come over to our classroom, just like talk with us for a couple of minutes.
Kuldeep was pulled down by mathematics, 65, 67, 48. He surprised me. Yesterday he did. By the way, our best is from Madipakam, Chennai. We got 48. Neeral.
48.
48. Yeah, 48. From my center, Madipakam, Chennai. And the other center, which is Ashok Nagar, got 169, 248 as well. They were also our student. So there is a click, I would say, up. That click you can make yourself privy to with all the allocates, accolades, I will say, not allocates. Accolades. Why? Because accolades is more relevant over here than allocates. Allocation will come later. Let us get into this. I'll let you know what they are and how did they prepare, what did they do. Of course, Kuldeep must have apprised you on what he has done. But to add to him, on an individual basis, we need to have a chat with him. We'll be getting into a deliberation someday or the other. For now, slightly be occupied with the other result, they will into compilation. Okay, so dl cross r, mu naught 4 pi. What is mu naught 4 pi, dear? Mu naught 4 pi is what to us? Mu naught 4 pi is the constant of proportion. Fine?
Yes, sir.
Okay. Please be very careful. What happens to general to student? They will say, okay, I have to find what I'll do. This is dl, this is r, dl cross r into the board. Into the board is okay. We'll buy that idea. Certainly, we are professing, we are to buy. But into the board is not to be shown over here. You're not finding field over here. Okay, dear?
Yes, sir.
What do? dl cross r, take it to the point where you have to find. You have to find over here.
Yes.
So you show into over here. Are you getting it?
Yes.
Into over here. This is the read for this point. Going to current element. Current element of what length? Here.
Yes, sir.
Okay. This is the basic. This is what the building block to us for any configuration. As we have, if you can recollect, we have 1 by 4 pi epsilon Q1 Q2 by R square as a Coulomb's law, and from there we build it up. Here, what we have at disposal is mu naught by 4 pi I into dl cross r by r cube. From here, we will build up for different configuration yet again. Fine, there?
Sir, well, when they were initially making their observations that led them to this formula, they would have to have made observations on a single current element. But how would you isolate the effect due to that single current element from all the other current elements that are also out there?
Well, good question. I won't say they need to isolate. The only contention, what was the bone of contention? The bone of contention being I want to associate vector to it, correct?
Yes, sir.
There is no need to take a curvilinear one, what I have shown on board. They can take it of any length. It ought to be assigned just a vector. That's it. You take up infinite length, any length it may be. You're getting it? I'm making it incommensurate with what student may ask. So it is generic to me. You're into experimentation, you can go specific, right? Yeah.
Yes, but how would you measure the impact the sine of the angle has between the current element and the point?
That
Sir?
it takes, that is what I said, it takes a couple lot for observation to get formulated. What they would have seen, I'll let you know. Let me go brain there. They would have taken different length. By length, they would have gotten, okay, it depends on length, fine. Then for that length, they would have taken different points. For different points, they would have got, okay, what is not changing is direction, but certainly the read is changing. The moment read is changing, you will get some inkling on why is the read changing. There can be two ways to relate it. One, the length is changing. Second, the angle is changing. So they ascertain their position on length and then they came to angle. See, we can only be into, we can situate, we can say everything is honky dory to us as of now because everything is known to us. Right? It's
Yes.
not that simple, easy walking path. So you have to get into multiple experimentation. Yeah. Homocellular addition, right? How many?
Couple of thousand, I guess.
Few papers are up, few are incognito. Doesn't take away from their work.
Yes.
This is what to us, and this is what we'll make good of. We're finding, we certainly do, and we'll always be claiming and finding virtue in their work, find virtue in their sweat, blood, and I will say tears. It's a lot. So DL cross R by RQ, this is what we have. We are to build up now. We'll take different configuration. The first to begin with is, as I said, let me go with it, a straight conductor. Infinitely long straight conductor. Let us find magnetic field generated by an infinitely long straight conductor carrying current I. Infinitely long straight conductor carrying current I. We are aware of the only formula at our disposal being mu naught by 4 pi I dl cross R by RQ. That's the only formula, that is the only where we can cite repose or we can find equations into coming stemming from. Okay?
Yes.
What I'm to do, I'm to take a point. I'll take a point for you. This is a point P that I'm interested. I'm interested in finding effect at point P owing to infinitely long current carrying conductor. What I'll have to do goes without saying. I'll have to just oppose it to what known to me. And what known to me is only for current element. Therefore, I'll go for checkering. I'll go for smothering of it. And we'll take a shot. Yeah? Just taking one point, just taking very small length, and that qualifies uses of mu naught 4 pi ideal cross R by R. What is R to me? This is R to me. Marking it out here. This is R to me. This is the angle which I am to mark as theta. I write direction first. DL cross R into the board at point P. Correct? Yeah.
Yes.
Rather, you take anywhere DL, you will get at point P into the board. Agreement?
Yes, sir.
Type it or not? DL cross R into the board?
Yes, sir.
Okay. So with your consent, let's move forward. Direction is no more a concern to me. I can go scalar. Right?
Yes, sir.
You can go scalar. We will accordingly go scalar. I'll find only dB for you. dB is what to be now on scalar front. Mu naught 4 pi I as it is dl r and sine of the angle theta divided by r cube. Getting it here?
Yes, sir.
What we get? Now, the answer is here over here being theta, dl, and r. They are to change as you move to capture minus infinity to plus infinity. All are to change. We'll change dl, yes. We'll change r. We'll change theta as well. It will relate. They can be easily related. They are relatable. Tell me what we write for dl. dl magnitude is nothing but dy magnitude. I take this y, right?
Yes, sir.
Okay. And y is what, media?
Yes, sir. Y is r sine theta.
Okay. So if this is small, this is d. This is d to me. Okay.
Yes, sir.
What do we get there? This angle is theta. This angle 90 minus theta. This becomes accordingly. We'll write for y and r relation. Tell me what will be y and r relation.
So the angle just opposite, and not opposite, is like the other linear angle associated with theta would be 180 minus theta.
Yeah.
Right. So r would so y would be r times cos 180 minus theta.
Okay. So this will be how much? 90 minus theta, right? And to ask, tell me, yeah, theta minus 90 or 90 minus theta.
So you would go 90 minus 180 minus theta. So you'd get no, theta minus 90 actually. The opposite. Theta
We
minus
write as theta minus 90. Okay, dear?
Yes, sir.
Okay. Now tell me what relation y and d share. Tan of the angle theta minus 90, right? What is this for us?
Y by d.
Y by d. Okay. What will be 90 minus theta? Theta minus 90. What will be theta minus 90? Minus of what theta?
Yes, sir.
Okay. We can write y as minus of d cot theta. Okay, dear?
Yes, sir.
Okay. To make it simple, what I do over here, I write this angle alpha. Okay, dear?
Yes, sir.
It's a very slightly complicated over here, so I take alpha and go by tan alpha, right, dear?
Yes, sir. I actually wanted to propose that a lot earlier.
That is better. That is better. So, as per word from your mouth, tan alpha is what to us here? Tan alpha is y by d. Y is equal to what to us? The tan of the angle alpha. Accordingly, dy is what to us? D sec square alpha into d alpha, right?
Yes, sir.
Okay, good. You please accept it. Natum, are you calling? If I'll accept you, then I think I'll get disconnected with Vasudev. Natum, better you take from here. You will further it later. Come on. Okay, so dy is equal to what to us? D sec square alpha d alpha. Correct, dear?
Yes, sir.
Okay. Use equation out here. Mu naught as it is. 4 pi as it is. I as it is. Instead of dl, we have d sec square alpha d alpha. Okay, gotten. Now what else?
Or sine
What
theta.
else?
Sine theta by r
Sine
squared.
theta. What we can write theta over here as is 90 plus, this will be 90 plus alpha, right?
Yeah, yes, sir. 90 plus alpha.
Theta will be 90 plus alpha, right?
Yes, sir.
Exterior angle.
So that'll just be cos alpha.
That will be sine 90 plus alpha, which will be cos alpha, isn't it?
Yes, sir.
Okay. So I write over here, making good of trigonometry, cos of the angle alpha divided by.
R squared.
Now, here I have it in here over here. Okay. Divided by r squared. Fine. Here we have replaced, right? Here we have replaced by d sec square alpha. This should be d. Okay, now suggest me r cube or r square as we have. R square, what will we replace for r squared here as per the figure that we are in? R is variable. I need to replace it. We need a replacement for r or r square.
Y
R can be
cosecant alpha.
d sec alpha, right?
Yes, sir. Okay.
Okay,
Okay. Well, d sec alpha will also work actually. That's easy.
d sec alpha,
Yes,
right?
sir. Yes, sir.
Okay, what we end up getting is mu naught 4 pi I d sec square alpha first, d alpha and divided by r square cos of sec q alpha, right?
So isn't that sec square? How did we get sec q? Okay, okay, fine,
Square
fine.
of
All right, I got it. I got it. I got it.
square is q,
Yes, sir.
right?
Yes, sir.
Okay, putting it down to mu naught 4 pi I d cos alpha d alpha. Okay,
Yes, sir.
go for integration now. What do we get? Tell me please. What is the term d square over here? So d square over here as well. Then what do we get?
So you should be getting mu naught
Integration
by.
of cos alpha will be sine of the angle alpha.
Yes, sir. You've got to integrate from minus pi by 2 to plus pi by 2.
Correct. Which will get us
So
2. Correct.
yeah, so that'll get you 2. So you get mu
Correct.
naught by 2 pi id.
Jerry, I prefer not disturbing the constant. We have a constant for it. So mu naught 4 pi, I'll keep intact. And the third, we get mu naught 4 pi twice I by d, correct?
Yes, sir.
Okay. If it is semi-infinite, a term coined in physics, you integrate it from 0 to pi by 2, correct?
Yes, sir.
Okay, that'll get you, you know what. Fine? So this is for a wire which is either infinite or semi-infinite on length. If otherwise, you know what is to change. Given to you a wire, let us say, with subtending angle 45 degree from one end and 90 from the other end, what you have to do over there, you're aware of it, right? Yeah.
Yes, sir.
There's further from straight current carrying conductor. Let's move to a conductor which is circular in shape. Write down. Let us take a circular conductor of radius r. Let us take a circular conductor of radius r carrying current I. Carrying current I. Find magnetic field generated at a point P on its axis. At a point P on its axis. Before we elucidate, what I am to take is a question. So let's take a question on the previous concept. I'm not scaling the question directly. I'm not going for the second photo questions. I'm not scaling the question on a concept that we have taken. So let us elucidate or establish, cement the concept by a question. Right, India?
Yes, sir.
What's given to us is a structure. This will be used. Formula will be used. So what I do is I take a cross-section view. I take a cross-section view of an arrangement. What arrangement it is? We first understood. This is the arrangement we are referring. Okay, now what it is? It is made up of infinite wires. 1, 2, 3, 4, 5, 6, 7, 8. Multiple wires. Okay, dear?
Okay, sir.
They're all infinite on length. We cannot see the end, we cannot see the beginning. When I cut, I get to see this cross section, right? Right, dear?
Yes, sir.
The structure is said to how's the current I, let us say, in totality, right? What current it is housing is I given to us.
Yes.
We're supposed to find B field at its center, this being its center assumed. Only B field at its center. Center of this arrangement. There can be myriads of center, you're aware of it. I'm just showing one of many. What will be B field here? B field generated by the structure. How will go about it?
So well, we
On
already know it's 2 mu by 4 pi I by d for one wire. We just need to scale that up. I mean, actually, it doesn't really depend where the wire is as long as it's a circular arrangement. So can you still say it's the same formula? 2 mu by 4 pi id.
You can use it for a wire. I don't have any quants uses of the formula mu naught 4 pi 2I by d. So far as one wire is concerned, that you're having multiple wires over here. And as you said, B field should depend. I would like you to throw more light on it. Could you substantiate your claim that B field will not depend on the point which we are associating infinite length to?
So the field here is radially symmetrical, right? So if you take an infinite wire, it doesn't depend where you choose a point. As long as it's a certain distance away from it, it has the same B field.
It is symmetrical, and how it's to change. If you change point, it will get you circular field, correct?
Yes, sir.
Around the infinite wire, dl cross r, if you keep on joining, you are going to get a locus, which is circle. So you'll get on a family, we will say, of concentric circles. Every circle will denote same magnitude, but the direction is subject to point of interest, right? Yeah.
Oh, okay. So the direction, yeah, the direction does differ.
Yeah.
Okay. All right. So you valid these as. So I was working with a similar mindset you would use for if you were, for example, calculating potential. That you just added the scalars. You can't.
That holds water. That holds water if you have same direction in consideration. Where direction is to change. What you ought to do, dear? Tell me. Suggest me a path. Walk me through.
So if you started with one wire, for example, if you started at the left bit of the wire, then because of that, the magnetic field will be pointing. Well, which way is the current going? Into the screen.
Take your suit.
Okay,
I'm taking it up.
Just apply the right-hand rule. Then, due to that current element, the magnetic field will be facing the upward direction from the way we're seeing it right now. Right, and as you move around, the magnetic field will turn anti-clockwise until at the very right it will be facing directly downwards. So you say because of symmetry there can
downwards. Did I hear downwards?
Sir?
Did I hear downwards?
Downwards. Yes, sir. Downwards.
If I take a point over here, dear.
There's at the other extreme end.
Out. I have taken current out. Which direction are you suggesting?
So it would be something like this, like the line y minus x.
Just now I did tell you that will be family of concentric circles, right? Yeah.
Yes, sir. So you can just extend the radius of the circle until it's tangent to that.
Okay, but the direction you said downward, it should be this way, right?
Yes, I was talking about the other extreme point, all the way to the right.
Good enough. I'll drop on that case as well. I take this one, then symmetric point. There you go.
The right.
Then you go the top one, and then you go the other one, right?
Yes, sir. So basically, it starts being vertically upward and it eventuates to being vertically downward.
Yeah, they'll get anal. The vertical will get anal. You're getting all the horizontal component is what we from here extrapolate. Correct? Yeah.
Yes, sir.
With that inference, if you have to move forward, there is no need to find dB vector. We can go with a component of dB vector. Correct?
You just need to essentially integrate cos of that through.
Accentuated. only the x will get accentuated if I am to deem horizontal x, correct?
Yes, sir.
I am to take horizontal as x, dv is this for me, break it into dvx, dvy, this will be dvx for me, dvy nonetheless is to add up to 0. It doesn't add up going for calculation of dvy. We go directly for calculation of dvx. Okay. What will be dbx? You ought to tell me now. Take any position out here. I have taken a position, some position you may take. I have taken a small length, and that length is being marked by me r d theta. Find here.
Yes, sir.
That length is being marked by me r d theta. If phi is to bear current I, then r d theta, phi means pi r, right over there. Then r d theta will bear what current? You can mark it as I by pi r into r d theta, correct here?
Yes, sir. Cancel that.
Upon, figure it as I by pi d theta, you will have what angular as well. This is di for me, small current, correct here?
Yes, sir.
Is to generate what we feel. Let me write it down vectorially first. dv is equal to what to us? Mu naught 4 pi I into dl cross r by r cube. This is the formula. Over here, I need to find dvx. That
Yes, sir.
doesn't matter to me. So mu naught 4 pi intact. I is di for me. I'll write down later. dl. What is dl to me?
Uh,
Certainly. What will be DL to me? Now, DL, I need to ask. Please be very careful over here, dear.
okay, sir. Yeah, yes,
I
sir.
must be careful. I have a basic formula. You have a better version of this. A better version of this is what will be magnetic field due to infinitely long current carrying conductor. That is known to you.
Yes, sir.
We can directly go for what will be B, which you will write small, of course. Why? Because you will integrate over the length. What will be B due to this wire? This wire is not this way. This is not the length. Wire is infinite, correct?
Yes, sir.
Which formula we may use? Straight we can use, okay, mu naught 4 pi twice of whatever current it is carrying
By
divided by R, capital R, where capital R is the radius, correct?
yes, sir.
Or the distance. Yes, that V or dV, whatever you write, will be in this direction, correct?
Yes, sir.
You can break it in two and find what will be dvx. So I write dvx now here, dvx, and you know what I'm referring to. I'm referring to an infinitely long current carrying conductor, this one. What is now to be placed for di is I by pi into d theta, agreement?
Yes, sir.
Okay, so mu naught 4 pi twice of I by pi into d theta, done. But this is not dbx, this is dv. We require dbx. What should I do? I'm taking this angle as theta, let's say. This ought to be then 90 minus theta, right? Yeah?
Yes, sir. So sine theta, basically.
So what do we have? Cos of the angle 90 minus theta will get us
Sine theta.
sine theta. We write over here sine of the angle theta. This is dbx for me. Please go for integration. Let me know the end result.
So we have to integrate from theta is equal to 0 to theta is equal to 2 pi. No, so theta is equal to pi. 0 to
2
pi.
pi, pi.
0 to. Okay, 0 to pi. So yeah, even that gives you 2. So mu naught by 4 pi times 4I by pi r.
So mu naught I pi square r, is it so?
Is it pi squared? Oh yeah, yes sir. Mu naught I by pi squared r if you do not keep that constant intact.
Yeah. That is what I prefer. Nevertheless, this is what we are getting in totality, in its entirety. And what else? If you have been any other angle, I presume you can very well justify it. I'll be getting you other angle in the test.
Yes sir.
For example, it's subtending 90 degree. And what I do, how I to execute,
So left
what
hand.
formula you want to then get.
Do the same
Kind
integral
of?
for both the components.
Yes. Okay, dear?
Yes sir.
Okay. Now we go for the theory portion, which I was next to take, it being a circle.
Yes
A
sir.
circle which is containing what current? It is enveloping a current I. And what is that to produce on its axis, which will further to the central point. So instead of going the other way around, I'm taking a general case. Generally what they do, they find for the central point first and then go for the axial point other than the central. We are going for the axial point directly. By a tweak, we can change that axial point to central point later. Fine, yeah?
Yes sir.
What we do, we draw for the case. We have a circle.
So another thing, could you somehow take out some time later to revise the T dot N formula for calculating the tension in a string that you taught us last year? T dot
Yeah,
A,
sure,
I
why
think
not?
it was.
Yeah,
Because
why not?
I realized I didn't note that down properly and I have no idea how to solve those problems now.
Get me some?
Yes, I'll get you one of them. It's actually one from the test last time. So
Yeah.
me. Yes.
Are you reading it down?
I don't have it now. I can get it to you later.
Okay. We'll take T dot A, right?
Yes, sir. That
There
method.
are options out there. Just tension dot with acceleration should be 0. Why? Because work done on inextensible string, if we have taken, and we do take those, will be 0. Get from there. Net work done. Anyway, we'll be taking it as you do, whichever form you want. You want to take it now? We'll be taking it right away. No issues.
Yes, I don't have the problem on hand right now. I'll send it to you later.
So this is the ring choice. There are two takes on it. One is what you have in NCERT. What they do, they find DL cross R. They take, this is the plane of ring, correct? Yeah. This is the plane of ring, correct? So I take a ring on this. I take small element. I'll have to checker it again. As you know, the only formula at our disposal being mu naught 4 pi I into DL cross R. So I have to break into small parts. I take DL. I know what is R, right? I know what is R. Getting it here?
Yes, sir.
And then we find DL cross R. DL R will be in which direction? This direction. Getting it?
DL. Okay. Where is DL pointing?
I've taken this to be the ring.
Yes.
So take a small element at the top, DL.
Yes, sir.
This will be R.
Mm-hmm.
An angle between DL and R, take anywhere will be 90 degree.
Yes, sir. So something weird thing like this. Yeah, it would be pointing up. Yes, sir.
It is this way. This is what you get. Okay.
Yes, sir. Okay. I get it.
DL R. Angle how much? 90 degree. So DL cross R will be in this direction, correct?
Yes, sir.
What do we do? DL cross R top. Then we will take DL cross R from bottom. We get a canopy at P, right? This way.
Kind of a cone.
Right? Kind of
Yes,
a cone, right?
Yes, sir.
So this canopy will get me field in which direction? Along the axis.
Yes,
Because the other is to get angle, right? Yeah.
Yes, sir.
So every point there's a counterpoint. So the other, in any direction you take, will get angle. This will get assimilated. And accordingly, we have to get in which direction? Along the axis. Agreement?
Yes, sir.
This is one way of understanding it. Other way, which is vectorially understanding it, is you write dl vector. You write dl vector. You write r vector. And then find dl cross r. Okay?
Okay.
How do we write dl vector? An obvious question. How will I write dl vector? For that, what I'll ask you is, draw the plane in which the ring is housed. So ring is housed in its plane known to us. It is ZX plane as per the depiction on board, correct?
Yes, sir.
What do I do? This is my ZX plane. I'll show it to you, right?
Yes, sir.
X was towards you, Z was this way, right? I do it this way. It's come this way, Z up, correct?
Yes, sir.
Let me draw the case for you. Let's come this way, and Z is up, correct?
Yes, sir.
Current was in what sense? I took it this way, so let us stick to it. For me, it is clockwise, right?
Mhm.
When I make it this way, it will go this way.
Yeah. Yes, sir.
Look
Anti-clockwise.
it it was this way. I go this way, so it will be this way, right?
Yes, sir. I get it.
So this is the direction of current. I show it this way.
Yes, sir.
DL I have to take. Okay? I have to take DL. I have to write DL. I know the radius. Now this representation you will not be getting, so please be very careful.
So,
The way you'll be getting representation, the vector representation.
Sir?
This representation will not be getting.
Yes, sir.
Vector representation will not be getting. They will take the cone and write the final equation. So DL, what is DL? Magnitude wise,
RD theta.
DL is what to us? Let's say R d theta. In case I have taken this theta, right?
Yes.
Now DL vectorially tell me, dear, what will it be? So this is R, I'm just magnifying it a bit. This is R d theta length for me. This is DL for me. What about the angles? If this is theta, what angle do you want? I want angle in this direction. I want angle in this direction. Magnifying it doesn't sound sense. It should be this way, right? Right? Because DL itself is very small, but I'm just magnifying it for my convenience. Right here.
Yes, sir.
So this is theta. What this angle be? Tell me.
So that'll be theta 2. Yeah.
Yeah. This will be theta as well. What do we get to see from here? R d theta cos of the angle theta in the direction I cap. Got it? First one.
So wouldn't it be minus I cap?
I have taken x in this direction. My x will be this way,
yes.
right?
Okay, I get it. Okay.
Now what else? The other one. R d theta sin theta. Which direction this one?
Minus k cap.
Minus theta. This is DL for me. DL bottom.
Yes, sir.
What about R? R we can get easily if we write coordinates of the points. It will be easier. What is coordinate of this point? X coordinate, Y coordinate, Z coordinate. Tell me, dear. X will be R sin theta.
Yes, sir. R sin theta.
Okay, Y will be 0.
And Z will be R cos theta.
R cos theta, right? So this will be tail of R vector, correct, dear?
Yes, sir.
And what about head of R vector? Head will pointificate point of interest. And point of interest falls on y-axis, correct?
Yes, sir. So 0, comma something, comma 0.
So y will be as per what we want to take it. Let's say y and z will be 0. Fine?
Yes, sir.
Okay. What is r then to us? R vector is 0 minus r sin theta I cap plus 0 minus y j cap plus 0 minus r cos theta a cap. Fine, yeah?
So I think you made a mistake take 0 minus r sine theta. That's fine. Shouldn't it be y minus 0?
It will be y minus 0. Yes, you are absolutely right. It will be y minus 0. My bad. Yes. How good?
Yes, sir.
Okay. Now what we have to do? We have to find dl cross r. That's it, yeah?
Yes, sir.
Not 4 pi we know. Dl cross r we have to get from there and we'll divide it by r cube. That will get me a form. Can we do that? dl cross r we have to find. Tell me what will be dl cross r. Here you know, r you know. Find the cross product, please.
Yes, sir.
So far as RQ is concerned, its magnitude, we can place it as per what we are getting, correct? Which is magnitude of R, correct?
Yes, sir.
We see to it what we are getting. Because the factors are to reduce to 0 when you will integrate. If you will integrate over theta, factors are to reduce to 0. Which factor will reduce to 0? You have to get me something being on there.
Yep.
Factors. dl cross r I j k dl now, which is r cos theta d theta 0 minus r sin theta d theta. Out of the realm, out of the ambit, differentiate. Then is minus of r sin theta I minus of r cos theta. Okay. Then cross r. What do we get?
Yes, sir. One second. My cross products are a bit rusty.
I out, bracket open, this will be 0. This will be getting me minus of r y sin theta d
D
theta.
theta. Yes, sir. And with
J, bracket open, this is this. What is this to get me? Minus of r cos squared theta d theta.
so could you write it adjacent to the I component because I can't see it?
Okay, just a minute. I'll be writing it up. To the camera a bit. Let's check. Visible? Any
Yes,
good?
sir. Yeah, I can see it now.
India?
Yes, but you're kind of in the way.
Okay, why kind in a way? Look at altitude. Check.
A little lower. Yes, just 1 second. Let's go today. Yes, I got it.
Got it?
Yes, sir.
Okay. And then the last one. So the last one, K cap. R over here, R cos theta over here, R cos theta over here, right?
Yes, sir.
Correct step for you. K cap, bracket open, we get it as?
So I think you're
Minus-
multiplying the wrong ones. Shouldn't it be r cos theta d theta times y?
Yeah. Or this one, right?
So you're writing for k cap, so it should be r cos theta d theta times y.
This one, right? This will be 0 and this will be minus of answers plus. So r y sin theta
Yes, sir.
d theta, right? Okay.
So if you're calculating for the k component, shouldn't you take the first two
Will be the
columns?
r y cos theta d theta.
Yes, sir.
R y is be cos. R y cos theta d theta, right?
Yes, sir.
Okay. Now go for integration, please. R y cos theta d theta. Tell me, when you integrate, what you'll be left with? Which term we are supposed to be left with? What about y? Let me remind you on y being a constant, okay?
Yes, sir.
Y is it variable out here? Y being a constant, you are integrating over theta.
Yes, sir.
Theta will be varied from 0 to pi, 2 pi.
So
Theta will be
we've got
varied.
cos square theta and sin square theta in the same term, so that just tantamounts to -1. So we get minus r d theta, and we are adding, well, d theta from 0. What are we integrating over again?
0 to, we have to integrate from 0 to 2 pi.
That doesn't seem like it's going to 0 because integration of theta is just theta. So
This one is cos theta, will get you sine when integrated. Y
So-
being a constant.
okay, wait. What's supposed to go to 0? The z component is supposed to go to 0, right?
No, no. Why are you supposed to place anything at 0? Over here, whatever we are getting, we are going according. In
Yes, sir.
accordance with vector calculation, we have taken vector into consideration and accordingly placing the values.
Yes, sir.
Whatever we are to get mathematically. We are not to go there, our brain. That we'll be doing when we are finding as per NCRT, DL cross B. Okay? Whatever we got, organically we have to write. So I have to integrate this, I have to integrate this, I have to integrate this.
Yes, sir.
All the limits that we have to place from 0 to 2 pi.
So then, well, naturally, the
Sin and cos, will be left with anything.
no,
They are having period from 0 to 2 pi.
yes, sir. Sine.
Okay, 0 to 2 pi period, correct?
Plus, yes, sir. You get the same value that minus that 0. Okay, I'll consider. Yes. Sir.
So, they vanish. The term that you are left with, you know, J
That's the
cap.
J component.
You should be getting that only.
Yes, sir.
Can you get me the formula now? Not 4 pi I into dl cross r. What is dl cross r? Let us write it down. Mu naught 4 pi I as it is dl cross r. What did we get? Tell me here.
So minus j cap r d theta. Well,
Okay.
we have to integrate that, of course.
So r d theta minus j cap direction is not now material.
Yeah.
Divided by, what do we write?
Yes, sir. Divide by.
Divided by, what do we write? R cube?
Yes, sir.
Divided by r. This is what we are getting, integrated, 2 pi. Not 4 pi, mu not 4 pi. I into r into pi divided by r into dj. If I left anything anywhere, remind me.
So I can't hear you.
If I left anything anywhere, do remind me of the same. I think I have. I have not written r square. I've been r square, right? The j term, r square, correct?
Yes, sir. It does seem like it.
R square, so this will be r square, correct?
Yeah. Cos square e theta square. Yes, sir. It should be.
Okay. But then we are left with this mu naught 4 pi. Now there is a term which I am coining, and that term is called magnetic moment. What is magnetic moment? Magnetic moment is simple product of current with the area encapsulated. It has got a direction to its merit. We get the direction by curling our fingers. If we curl our finger in the direction or the sense of current, better sense we say, not direction, in the sense of current, thumb will point in the direction of mu vector. Mu is the sign we generally attribute to magnetic moment. Okay, dear?
Yes, sir.
What can we write it down over here? Vectorial is price of mu divided by r cube. Do check. I r square 2 mu I.
So r squared I
I
pi.
r square is the area. I is the current.
Yes, sir. So pi r squared
90.
I is the magnetic moment.
Yes.
So one question though, how is I even existing here?
How is I existing here means there is a current. Oh, he made the flow. That's the reason I asked you which way you want to go.
Oh, yeah.
I
So we
established over here.
okay, so we're not
Because
exactly talking about how it came into existence.
there should be some in and some out point to it. Okay, it cannot be a perfect circle.
Yes.
Okay.
Or maybe it's an return-induced EMF or something.
We will do later.
Yes.
Okay. That will generate provided we are changing B field. And then we'll ask you what kind of field it is. Is it conservative, non-conservative? Because we have some weird answers over here to follow. We have potential defined. Potential is defined for conservative. Maxwell is in odds with it being conservative. How much will wait later? For now, simple. Mu naught 4 pi twice mu by r cube. Mu over here is something of great import. We'll be studying about magnetic moment for different structure. For example, one magnetic moment for shell having charge Q on it. What will be magnetic moment for rod which is rotated having charge lambda, current lambda on it. So those are the terms we'll be dwelling on next. For now, this is all for the day. What I say. And you have to be further with subsequent series question then.
Sir?
Take a 5 minutes, so be it. Some sequence and series questions.
I'm sorry, is this another instance where I had to make my own question?
Yeah.
So I wasn't aware of that. Yeah,
Even one thing you can do during the course of it being done. Nothing much. Sequence series is a very interesting topic. And you have much to pull out of hat. You can say a rabbit out of hat. So many a surprise up your sleeve. You can pull one. Okay?
Yes.
So you want to break up 5 minutes or when did continue?
So I currently do not have a question with me to
Give me a
discuss.
question.
Sir?
Can get in 5 minutes?
I doubt how creative I can get within
I'll ask
5
you a question.
minutes.
Fine. In that case, I'll get you a question. You need to think about it and get back to us. Fine?
Yes, sir, sure, I can do that.
I can give these questions. There are 4 or 5 questions I'm narrating to you. Shakram is narrating to me. Shakram, please you do. You do. Narrate, come, narrate. Narrate the questions. Shakram, I'm narrating those questions to you. You can work it out and we'll be back on it.
Yes. Hello.
So one of them has a little bit of data, that's why I'm simply writing it because some parts are not able to speak properly. So in the first question, you need to find the value of half of b raised to 1 by 8. Is that visible? Half of b raised to 1 by 8.
Yes.
Alpha and gamma are the roots of ax square minus 4x plus 1 equals 0. Beta and delta are the roots of x square minus 6. Bx square minus 6x plus 1 equals 0. Alpha is to minus 1. Alpha is to minus 1. 1 by beta. 2 by log the base 3, 9 gamma. And delta by delta square.
Excuse me, but you'll either have to speak louder or write clearer because the audio and the video are both equally terrible. Yeah, I can read that.
Okay. So you need to find if these are the information given.
Yes.
And you need to find value if alpha is to minus 1, 1 by beta, 2 by log to the base 3, 9 gamma, and delta by delta square are in AP.
Okay, so what is the half b to the power 1 by 8 thing? We need to find that.
They are the equations. Ax square minus 4x plus 1, bx square minus 6 plus 1. And we have these information. They are the roots of the equation.
Okay, what's half b to the 1 by a then?
So B, A and B are parts of the quadratic equations. Alpha, gamma, and beta are the roots of the quadratic equations.
Yes.
You need to find the value of B and A and then compute what is half into B raised to 1 by.
Oh, okay. I get it.
Because now I'm not very sure. What do you suppose? What is the order to be done?
I didn't get you.
So what have you been told to do it now or just note it down and then do it?
I write it down. Just give me all you got. You can do it then. Maybe it'll save you some time too. What's the last term that's in an AP?
Delta by delta square.
Is there a reason you chose that specific representation? I
Not
mean,
exactly.
instead of just writing 1 by delta.
Okay, I could have written 1 by delta, but there was a way I had to choose it to make it seem a different one.
Alright, got it. Next question, please.
In the next question, you need to find x if you have an expression log base root 3 3 by 3 raised to, okay, so your log base root 3, you have 3 by 3 raised to, yeah, 3 by 3 raised to x plus 2. If I'll write few terms. Okay, first actually it should be finding x if 1, this term log to the base root 3 3 by 3x plus 2, and log 3 4 into 3 raised to x minus 1. If all these terms, so if one, this term and this term are in an AP.
The 3 terms are in an AP.
Yeah, 1, this log base root 3 by 3x plus 2, and log 3 4 into 3x minus 1.
Yes, okay.
After this, you okay. We have the sequence 1, 2, 4, 4, 4, 4, 4, and so on. We need to find the summation of n equals 1 to the 2000. And you have n. Then the n. So simply it means that you need to find.
Wait, 1 second. I can't read anything you've written after the summation.
Okay, so over here we have, I'll try to do it.
Yes.
N. T raised to n is the nth term. Basically, the summation of all the terms from first term to the 2000th term.
Yes.
Writing it is not visible. And the first term to the 2000th term, that is what was to be covered. Natural numbers.
I didn't hear what you said.
Okay,
Okay, what
so
do we got to do here? Okay, I got the series. We're going to take the summation of the series from 1 to 2000. And what should we do with that?
So you just need to find the value of all the summation from the first term to the 2000th term.
Okay, we need to find that value. Fine. Wait, don't erase it. Alright, go on. I got it. It's fine. I got it.
Okay. Okay.
Hey, buddy, in your first question, what was the third term
Yeah.
that was in an AP?
Okay. So this third term was 2 by log this 3 gamma.
Why?
The gamma, this guy. I don't know, gamma is how I write.
Okay, where did y pop in from? We've never used y ever in the
There's no
question.
why. Why is why we are writing gamma? I'm just writing gamma in that. It's not. There's no why. Why
Okay,
means gamma.
that's your gamma. Sure, interesting. I'm not curious how you write your y's.
See, I just put a little bit of a curl into it, so that makes it a little differentiable from the normal y.
All right. So that's what you
And
got.
yeah, I just have two more.
Okay.
Uh, so you need to find the value of n equals 1, 1994. So summation limits from n equals 1 to 1994. The value of n's, okay, minus 1 raised to n multiplied by n square plus n plus 5. Generalize and generalize the result you obtain for all n.
Wait, generalize for all n.
Yeah, so you get a result and then you can generalize that for all n, and that is what is being asked in the question.
Oh, so you want me to find that summation as a function of n that does not include the sigma. Okay. Just to confirm, the 1994 limit would be the independent variable in that case, right?
Yeah.
Okay. Alright, I'm done.
And the last question. So the last question, you have three non-zero real numbers. Three non-zero real numbers, A, B, and C. And their harmonic progression HP, meaning that 1 by A plus 1 by C equals 2 by B. So you have to find how many three-term HPs exist. Where A is greater than A lesser than B is lesser than C. A equals 20 and B divides. So basically you have three non-zero real numbers A, B and C, and they've been given to show, they've been shown to be given in a harmonic progression where 1 by A plus 1 by C equals 2 by B. So how many three-term HPs exist where they are in a strictly increasing order, right? And they're strictly increasing the positive integers, importantly strictly increasing positive integers where A equals 20 and B divides.
A equals 20 and B divides A.
A equals 20 and B divides C.
B divides?
C.
Okay. Alright. B divides C and ABC are positive integers.
Yeah, these are positive integers and strictly increasing positive. So A is less than B less than C. And just for further information, this question had appeared in RMO 2008.
That's a lot of necessary context right there.
Yeah. Okay, that is, I have more, but I'll keep it for this one.
Alright, okay, I got that one down too. Thanks.